था कंपनसेशन के लिए, नॉर्मली उन्होंने पहले ही कह दिया कि देयर इज नो कंपनसेशन, वो फिर अपने खुद ही एप्लीकेशन देगी विद प्रॉपर एविडेंस, और कोई से ज़्यादा ही लेने हैं। ओके जी, we were doing the method of partial fractions, 8.3 section of Thomas calculus book. And I told you before that we have a rational function. If we have a integration, if we need to integrate, we are required to integrate a rational function. A rational function is of the form p of x over q of x, where both p of x and q of x are polynomials. Q of x cannot be equal to 0 for any value of x, is not equal to 0 for all values of x, and for the polynomial, the degree of the variable is greater is non-negative integer, right? So for the integration of the rational function, you have to use method of partial fractions. That is, you have to break down, you have to decompose your rational function into some of the simpler fractions. Those simpler fractions are called partial fraction. The first step is to convert the improper rational function into the proper rational function, rational fraction, you can say, if it is a improper fraction. Second step is to factorize your q of x, that is your polynomial, in the denominator. Third step is to write the decomposition of the partial fraction. Fourth step is to determine those unknowns in the partial fractions. Fifth step is to integrate, the last step. Integration is very easy. We have discussed 4 cases. We have done case 1 and case 2. Case 1 is distinct linear factors. Case 2 is if the factorization is repeated linear factors. Case 3 is distinct irreducible quadratic factors, and case 4 is repeated irreducible quadratic factors.
मैम आपकी आवाज नहीं आ रही।
You can hear me?
Yes, ma'am.
We have done example 4. Now, case 3 is the q of x contains, the factorization of q of x is consists of irreducible quadratic factors. That is, if I have this irreducible quadratic factor x square plus 1, x square plus 1, let's say it is plus 2. Both of these quadratic factors are irreducible. They cannot be further factorized into linear factors, right? Because their b square minus 4ac is less than 0. You can check it. So for this, for the first factor x square plus 2, I will write ax plus b over x square plus 2. And for the second irreducible quadratic factor, I will write cx plus d over x square plus x plus 1. Now I have 4 unknowns, 4 constants that need to be determined by comparing the coefficients method. No shortcut method can be applied in this case because there is no linear factor over here. So this is my case 3. And if I have case 4, that is, if I have x square plus 2 whole square, x square plus x plus 1, then I will write ax plus b for x square plus 2 plus cx plus d for x square plus 2 whole square plus ex plus f for x square plus x plus 1. I have 6 unknowns that need to be determined. And then after, I have to do the integration. How you will do the integration, I will explain it in the example. So the integration basically of this x square plus 1 is, this is very simple. If you have linear factor, you have to apply the rule 20, natural log of this x minus 4. If you have repeated linear factor, then you will apply 1, for the linear you will write apply rule number 20, and for the with the power other than 1 you will apply the rule power rule x minus 2 whole square. For this you will be writing it's x square plus 1, you will, its derivative is 2x, right? Its derivative is 2x, and you will multiply it, and I can see x over here, so you will multiply it and divide it with 2, and you will get some constant. If b is, let's say b is 1, then I will write 2x plus 2 x square plus 1 dx. So this 2 is extra. I'm just integrating this, the second one. This integration is the same. Is equal to 1 over 2, 2x over x square plus 1 plus, break down this fraction. 1 over 2, don't forget about this 1 over 2. 2 over x square plus 1. Break down with this. The derivative is only 2x. ठीक है, तो ये 2 एक्स्ट्रा है ना, आपको अलग करना ही होगा. तो अब इसके ऊपर ये फंक्शन, नीचे फंक्शन, ऊपर डेरिवेटिव. इट्स इंटीग्रल इज ln of x square plus 1. What about this? 2 over x square plus 1, this 2 is cancelled with it. नीचे का क्वाड्रेटिक को ऊपर कांस्टेंट हो, then you will apply tan inverse formula. You have to do it by completing square. यहाँ पे completing square की जरूरत नहीं. You don't need to do the completing square because there is x square already. If you have an x term, then you need completing square. Here you will directly apply the tan inverse formula. That is this one. But this you need to for the quadratic factors, repeated quadratic factors or quadratic factors. Okay. Okay, let's see how you will solve this question. Now I have a proper rational function, so no need to do long division. So factorize x cube plus 4 of x, whose factorization is x into x square plus 4. So I will write a over x plus bx plus c over x square plus 4. I need to determine 4 unknowns. I can determine this unknown a by the shortcut method, that is by putting x is equal to 0 in this equation, not in this equation. And for the values of b and c, I need to compare the coefficients on both sides. Two equations basically. So after comparing the coefficients, these are the three values of a, b and c. And now about the integration procedure. I think this integration is a bit easy. I will do this. Now example 6 is, I have an improper fraction 4x square minus 3x plus 2 over 4x square minus 4x plus 3. Divide it. I will get this after. This is the result of the long division. Now I have to integrate this one. So integration mein I will explain each step and rewrite. After long division, this is my result. Okay, integration of 1 dx plus integration of x minus 1, 4x square minus 4x plus 3. Now 4x square minus 4x plus 3 is reducible or irreducible? Check it please. Find b square minus 4ac. Irreducible, so it cannot be factorized. So it cannot be decomposed into partial fractions. So here the partial fraction method is not applied. We just need to integrate this. एक ही factor है. Integration of 1 is with respect to x is x plus. Now I have quadratic polynomial in the denominator and a linear polynomial in the numerator. So I can make its derivative in the numerator. Its derivative is 8x minus 4. I need 8x. I have x over here. So first I have to multiply 8 and divide it with 8. That is 8x minus 8 over 4x square minus 4x plus 3. So the derivative of 4x square minus 4x plus 3 is 8x minus 4. I have 8x but minus 8 with it. So what will I do? I will break this minus 8 into minus 4 into minus 4. Or I will add minus 4 plus 4 over here. Whatever. Is equal to x plus 1 over. Now this 4 is minus 4 is extra. So I will break the fraction, this fraction, into two parts. One for 8x minus 4 and the other one for minus 4. I will write it 1 over 8, 8x minus 4 over 4x square minus 4x plus 3. And the other one for this minus 4. Minus 4. Don't forget about this 1 over 8. This is 4x square. Yes. ये यहाँ पे -8 है ना, -8 को ब्रेक करके लिखा -4 इंटू -4. ये -8 से पहले मल्टीप्लाई किया था 1 over 8. The function in the numerator with power -1 and its derivative in the function in the denominator in the numerator. So natural log of 4x square minus 4x plus 3. What about this one? This is -1 over 2 dx over a quadratic polynomial. What about this one? Yes. If I have a quadratic and a constant in the numerator and a quadratic in the denominator, I will use the completing square. I have to use the tan inverse formula. So 4x square minus 4x plus 3, after completing its square, it is 2x minus 1 whole square plus 2. Okay. So this is 2x minus 1 plus 2. The same one, minus 1 over 2. And this is 2 under root 2 whole square. 1 over a. My a is under root 2. Tan inverse of x over a. X is, one thing more I want to tell you, that is 2x minus 1 derivative is, I have to convert it into u because its derivative is 2. Okay. So convert it into u, solve it separately. सिंपल इसलिए कंफ्यूजन हो रही है कि यहाँ पे इसका डेरिवेटिव भी 2 आ रहा है ना. वो जब हमारे पास दूसरी सिचुएशन थी ना कि x माइनस समथिंग आता तो उसका डेरिवेटिव 1 था, तो मसला नहीं था. तो उसका डेरिवेटिव 2 है तो कर लेना. वो मैं ज़रा उसी चीज़ को एक्सप्लेन करना चाह रही थी ना. तो सेपरेटली आप इसको 2 से मल्टीप्लाई करके यहाँ से क्योंकि इसका डेरिवेटिव 2 आ रहा है तो ये 2 इसके डेरिवेटिव के लिए लिखा है. यहाँ पे ये जो 2 है ये इसका डेरिवेटिव से मल्टीप्लाई किया और डिवाइड किया. और यहाँ पे -1 over 4 का इंटीग्रल आ गया, -1 over 4 हो गया. 1 over a, 1 over under root 2 tan inverse of 2x minus 1 over this a. A is under root 2. This is your answer. बाकी जो दो टर्म्स हैं वो उसी तरह से आता है माइनस के साथ. ओके. This is how you will do this integration, such type of integration for quadratic factors. First you have to make the derivative in the numerator, multiply it with the coefficient of this derivative, that is 8, and then separate the extra term. Then break your fractions into two parts, apply formula 19 for this and tan inverse for the अदर वन और द अदर फ्रैक्शन। यहाँ पे आपके पास कंप्लीटिंग स्क्वायर से आपने करना, जैसे कि हमने दूसरे एग्जांपल में फर्स्ट सेकंड लेक्चर में किया था कंप्लीटिंग स्क्वायर। ठीक है, तो ये अंडरस्टैंडिंग हो गई है कैसे किया था। चलिए अब आप लोगों ने एक क्वेश्चन करना है। एग्जाम्पल ये सारी चीजें मैंने एक्सप्लेन की हैं यहाँ पे। Now you need to solve this example 8. Do the example 8. जल्दी जल्दी करना है, 10 मिनट के अंदर हम। Online students also need to solve this example 8. This is a combination of all the four cases. X into x square plus 1 whole square. First of all, check whether x square plus 1 is reducible or irreducible. After that, decompose it into partial fraction and then find the unknowns, and then after finding the unknowns, integrate. ओके जी, ऑनलाइन स्टूडेंट्स कहाँ तक पहुंचे आप लोग? वैल्यूज जरा देख लें अगर डिटर्मिन हो गई हैं। ठीक है, क्या आई? ए की वैल्यू, ए यही लिया है अगर तो ए की वैल्यू क्या आई? और बी की, सी की, डी की, ई की, गुड। आप लोगों ने याद भी करेगा इसको, आप भी करेंगे ना इसको।
मैम जी मेरी एक मिस्टेक हो गई है, समझ नहीं आ रही, आप चेक कर देंगे एक दफा?
ये अगर मिस्टेक होगी तो फिर आप उस मिस्टेक को फाइंड आउट करें, और अगर फाइंड आउट करने का स्टेमिना
मैम
नहीं है तो फिर करें।
नहीं मैम, फिर ना एक्स क्यूब के कोफिशिएंट्स की इक्वेशन भी सेम बन रही है और एक्स की भी सेम बन रही है, तो वो तो आपस में कैंसिल आउट हो रहे हैं। तो मुझे समझ नहीं आ रही मिस्टेक मैंने कहाँ की है। 2 दफा क्वेश्चन कर चुकी हूँ, वही बन रही है।
चलें जी देख लें, अब आपको बुक ढूंढनी पड़ेगी यहाँ से। ये देखें इक्वेशंस भी हैं ये मेरे पास, इनको देखो जरा। चेक करें फातिमा, ये क्वेश्चन क्या नाम है इनका? फातिमा ही थी। फातिमा ये चेक करें ये
यस मैम,
इक्वेशन की।
मिल गई मिल गई मिल गई।
ओके जी, इंटीग्रेशन करनी है और इसके बाद ये आपके पास ये यहाँ पे है 1 है, ठीक है। अपना से आप 1 ही है, ये यहाँ पे 1 है ना, ये के 2 है। तो आपको लग रहा है कि आपने 1 आपने भी कर दिया, यहाँ पे 1 है। इंटीग्रेशन करें, जल्दी करें। इसकी इंटीग्रेशन थोड़ी आसान है, इससे वाला था जो मैंने एक्सप्लेन किया था उस तरह की ही ध्यान में रखें कि उस तरह की ही इंटीग्रेशन आपने करनी है, जैसे क्वेश्चन में आएगी।
एक्सक्यूज मी मैम।
जी बेटा बताइए।
मैम ये x ओवर एक्स स्क्वायर प्लस वन होल स्क्वायर dx ये कैसे इंटीग्रेट हो रहा है, मुझे इसकी समझ नहीं आ रही।
जी क्या नाम है आपका?
मैम अहमद ताशफीन।
अहमद। ये बेटा ये आपका रूल, यू विल अप्लाई रूल 19 पावर रूल। फंक्शन विद द पावर -2 and its derivative is 2x। ठीक है, पावर रूल यूज होगा। पावर में से फंक्शन की पावर, अगर मैं इसको ऊपर लिख लूं बेशक, मल्टीप्लाई बाय इट्स डेरिवेटिव। पावर में एक ऐड करें डिवाइडेड बाय द सेम।
ठीक है मैम, समझ आ गई।
ठीक है ना, तो -2 + 1 इज दिस, और इसमें साथ में डेरिवेटिव, और इसी से आपने इसको डिवाइड करना।
थैंक यू मैम।
-1 से किया और ये 2 से आ रहा है। ओके जी, बाकी लोग भी इसको कंप्लीट करें। अगर कुछ मसला है तो फिर बताएं, क्योंकि एक पूरा प्रोसीजर है इसका, मेथड ऑफ पार्शियल फ्रैक्शन का सॉल्व करने का एक पूरा प्रोसीजर है, वो सारा आपको आना चाहिए। खासतौर पे ये इंटीग्रेशन फार्मूलाज ही यूज होंगे। मैंने बता दिया कि इन सब में आपके फार्मूला 19, 20 यूज होंगे एंड tan इनवर्स वाला फार्मूला यूज होगा। ये 3 यूज होंगे। कंप्लीटिंग स्क्वायर है कांस्टेंट है इन द न्यूमरेटर एंड क्वाड्रेटिक इन द न्यूमरेटर डिनोमिनेटर, देन यू हैव टू अप्लाई द कांस्टेंट। So we note that sometimes partial fractions can be avoided when integrating a rational function. For example, if you have this integral, u of x is already factored into x into x square plus 3, linear and quadratic. But if you look at it closely, you will see that the function in the denominator is x cubed plus 3x, whose derivative is 3x square plus 3. And if you multiply the numerator with 3, you will get its derivative in the numerator. That is this one. And the integration is very simple. Without using the method of partial fraction, you can integrate it. You can also integrate it by method of partial fraction, but then your calculations will be much more difficult than this. Okay, just some non-rational functions can be changed into rational functions by means of an substitution. That is, if you have this x plus 4 under root over x, then I can use u equal to x, substitute u equal to x plus 4 under the root, then u square is equal to x plus 4, x is equal to u square minus 4, taking differential, dx is equal to 2u du. Then this becomes x plus 4 is equal to u, x is equal to u square minus 4, and dx is equal to 2u du, which is now 2u square over u square minus 4. Now the powers are non-negative integers. So I have a rational function, polynomial in the numerator and polynomial in the denominator, but an improper rational fraction. So first I need to do the long division, and after the long division, we'll get this 1 plus 4 over u square minus 4. And then I need to factorize this, use method of partial fraction, u square minus 4, factorize it. Its factorization is, it is reducible quadratic factor u minus 2 into u plus 2. And we have already done this integration by using method of partial fraction. अब वो अभी हम आगे जाके करेंगे, okay? ट्रिग्नोमेट्रिक सब्स्टिट्यूशन वाले सेक्शन में करेंगे। तो ये दोनों तरीकों से आप इसको कर सकते। उसमें हमारे पास दूसरा मेथड था, एलएम नहीं आता उसमें, उसमें ही आते हैं सारे आंसर, वो भी अभी हम जाके आगे देखें। इसके बाद बैक सब्स्टिट्यूशन करेंगे, ये आपका आंसर आ गया। ओके ठीक है स्टूडेंट्स, ये आप लोगों ने ये प्रैक्टिस क्वेश्चन जरूर करने हैं इस वीकेंड के ऊपर, ये लाजमी करना है। जी हसीब। क्या हुआ? आंसर किस चीज? ओके जी, एनी क्वेश्चन रिलेटेड टू दिस टॉपिक, मेथड ऑफ पार्शियल फ्रैक्शंस? तो अब तक टेक्निक्स ऑफ इंटीग्रेशन में वी हैव डन बेसिक इंटीग्रेशन फार्मूलाज, integration by parts, and method of partial fractions. And the most difficult of all of them is that I find amongst the student is this one, trigonometric integral, section 8.4 of Thomas Calculus book 11th edition. 8.4. You have to integrate trigonometric functions. They can be powers of sine and cosine. They can have different angles. It is difficult because students don't know which identity they need to apply. They need to substitute. For example, cos cube of x. How to integrate cos cube x? So the only option that I can have is break it into cos square x, the power into cos x. Now I know the cos of x is the derivative of sine of x. So if I convert this cos square x into sine square x, then I can substitute the function and its derivative. So I will make use of the identity 1 minus sine square x, which is cos square x, into cos x dx. Now if I substitute sine x is equal to u, then its derivative is cos x dx is equal to du. My function, my integrand becomes 1 minus u square into du. Now this integration is easy. I have to integrate with respect to u. Integration of 1 is u. Integration of u square is u cube over 3 plus c. Back substitution, u is sine of x minus sine cube of x plus over 3 plus c. So this is how I will integrate it. Power of cos. If I have another odd power, that is 5, I can write cos square x, cos 4x into cos x. Separate only one power of cos x. Cos x into cos 4x. In place of cos square x, I will put 1 minus sine square x, whole square x. Then I will whole square over here. Before integrating this, I need to evaluate this whole square. Right? This is how I will integrate odd powers of cos of x. And similar procedure is for odd powers of sine of x. Right? So this strategy is applicable when I have odd powers of cos of x or sine of x. That is, the strategy is separate one power of cos of x and then convert the rest into the other one. And if I have this, the product of powers of sine and cos, what I am going to do? Which power I need to separate? The odd one or the even one? The power of sine is odd and the power of cos is even. I will convert separate this sine.
Sine of x को मैम
Sine 5x. Now, the derivative, sine of x is derivative of cos x. So I need to convert all these into cos x. This is already in cos x. Convert this into cos x. 1 minus cos square x whole square cos square x sin x dx. Right? And after substituting cos x equal to u, derivative is minus sin x. This becomes minus minus u square whole square u square into du. Okay. First open this whole square, multiply it with u square, and then integrate, and then back substitution. So I have only separated this term, this power, the odd power. No need to convert this into sine of x. Students यही mistake करते हैं, उसको उसमें कर लेते हैं और फिर एक खिचड़ी पक जाती है और फिर पता नहीं चलता कि what to do next. So make a mind what you are going to do. You are separating a power and converting the rest into the other one. So this is my strategy. If I have product of powers of sine and cosine, I will separate the power of the odd power and convert the rest into the other trigonometric function. If both the powers of sine and cosine are even, I will not apply this strategy. तब ये अप्लाई नहीं करेंगे, क्योंकि फिर क्यों नहीं करेंगे? क्योंकि अगर एक फंक्शन अलग करेंगे तो आपके पास फिर ऑड पावर आ जाएगी. ऑड पावर को आप साइन या कॉस में कैसे कन्वर्ट करेंगे? स्क्वायर रूट आ जाएगा, वो अलग कॉम्प्लिकेटेड आपके पास इंटीग्रल बन जाएगा. देन यू विल यूज हाफ एंगल आइडेंटिटी. दिस sin square of x is equal to 1 over 2 1 minus cos of 2x and cos square x is equal to 1 over 2 1 plus cos of 2x. And over here you will integrate it by using half angle identity. To 1 over 2 into 1 minus cos of 2x. Integrate it simply. The integration of cos of 2x is of 2x divided by the derivative of the angle. Derivative of the angle is a constant. That's why I am using this formula. Divided by its derivative, which is 2. And then put the limits of integration. What about this one? Sine 4 of x. 1 minus. Why 1 minus? Then use the half angle identity, which is 1 minus cos of 2x over 2 whole square. This becomes 1 over 4 1 minus 2 cos of 2x plus cos square of 2x. Again I have to apply half angle identity to this square and then integrate. I need to apply the half angle identity, this one. Okay. So summarizing all of these strategies, the guidelines are: if I have to integrate such type of integral, both the angles are same with different powers of m and n. If the power of n is odd, power of cosine is odd, then save one cosine factor, express the remaining factors in terms of sine, and then do the simple integration. And if the power of sine is odd, save one sine factor, separate one sine factor, and convert the rest of the factors in term of cosine. Then apply this. Use the substitution and integrate it simply. Two strategies, A and B. If the powers of both sine and cosine are odd, either use A or B. You can use either A or B. Your answer will be correct in both the cases. But if strategy say is both the powers of sine and cosine are even, you will use half angle identities. Also you can use this one, double angle identity of sine. That's all for today's lecture. The next class we will see what about the powers of tan and secant. तो इसकी बहुत सी strategies हैं. ट्रिग्नोमेट्रिक इंटीग्रल्स की। ये तो सिर्फ इस केस के लिए था, आपके पास हो सकता है कि tan मल्टीप्लाई हो रहा है, सेकंड मल्टीप्लाई हो रहा है, ये सारा आपने अपना माइंड को पहले देख के चलना है, ये नहीं कि बस लिख के जाओ और कन्वर्ट करते रहें, फायदा ना हो। ओके जी, एनी क्वेश्चन? फातिमा, यू हैव अ क्वेश्चन?
नो मैम।